Okay, welcome to your programming lecture. I hope you're excited because I'm super excited for you. We're going to learn this programming language called Python today, and it's super exciting. Oops, shouldn't have pressed delete. It's the language that is the most common one to teach to a student who has never programmed before in an introductory college class. So at UC Santa Barbara, where I came from, the first class that we taught students there is a Python-based one. And then we moved to C++. I think at Fresno State, at least once before I left, they started teaching Python in their CSCI 40 equivalent. But yeah, here we teach CSCI 40 and C++ immediately. So I'm excited for you because you get to be introduced to an introductory language. So I love Python. There are some things about it that are horrible, but you don't have to worry about them when you're starting out. Alright, so the first thing that we need to do, because it's a programming language, is to get it on our computers. It is not a place that you can go to easily and make it work on the internet, at least for the things that we'll be doing with it. So please go to python.org/downloads. You can search Google for Python and click downloads and then download it. You want to download Python 3. That's important. We want 3, not 2. 2 is old and we don't like it anymore. Okay? So let me write that. It will be the default version, but just for reference. V3, not V2. Okay? So there's that. Go ahead and download this and it'll work. In a pinch, like if you're on a Chromebook or something, at least for the first tiny bit, at least this week in this class, you'll be able to get by, search for like online Python, and surely one of these, probably, I've heard this one, REPL.it. It'll give you the ability to use Python inside of your browser, but we will be doing graphical things later, so this will not work, as far as I know. So in a pinch, you can do it online, but I would prefer it if you did it not online. Okay, so get Python and get it installed, and then in your computer, boop, it will be somewhere. Just go ahead and open it. You want 3.8, and you can, I want you to open this thing called idle down here, IDLE in all caps. If you open this one, it'll be just like a black screen, possibly white if you're on a Mac, and it will work, but it's kind of scary and weird. We don't need to start there. Okay? So idle is where we want to go. Idle, and it's beautiful. It opens up bright and colorful. And let's see if I can make this bigger for you, because you're going to want to see it bigger. Configure idle, please. Let's give it a nice font while we're here, and then let's make it big. I like 2 spaces for my tabs, but you don't have to care about that right now. Let's see, what's a good size for y'all? I think we can go bigger for now. Let's try 18. Yeah? Alright. This will be hopefully saved forever. Oh, just gotta make the window a normal size. Don't worry. Just gonna, there we go. Alright, so this is Python. This is called the REPL. REPL stands for read, eval, print, loop. So it is a loop. It's like a program within a program. First it reads, then it evaluates, then it prints. Oh gosh. But I'm trying to define it, so I should say this. Read, eval, print, loop. Alright, so first it reads, then it evaluates, then it prints, and then it does all of that all over again in a loop. Okay? So it is a program within a program, and it evaluates Python code. Okay, so we can type individual lines of Python. And I better drag this. It'll run that one line for us. And that's all we really need at the moment. Okay? So let's first talk a little bit about what Python is, because it's a programming language, and we've used Scratch already, but this and this are two completely different looking things, even though they do the same thing. So let's talk about what the differences are. Let's make sure I'm actually recording. Yes. Okay. So what is Python? So it's a programming language just like Scratch. It's a programming language, but it's not graphical. You can write programs that make pretty things. It just takes a little bit of extra work. Your code isn't blocks anymore. You don't drag it with a mouse, you type it. It's lines of text, okay? If anything, that's the main difference. It's not blocks, it's lines of text, okay? So if you want two things to run, if you want your two blocks to run, just like in Scratch, you stack them right on top of each other, in Python you say, I don't know, line 1. Then you say line 2 right after, okay? So if you want two things to happen sequentially, you just put them after each other. And we might not get to it today, it depends on how much we get through, but like if-else's with things inside, how in the world are we going to translate this into a graphical form? Or, sorry, from a graphical form into a text form. And there are ways. You can think of it like, oh, there's text inside, it's kind of over to the right a little bit. That's the idea, really. But yeah, it's not blocks anymore, it's lines of text, and each line has a specific meaning. Each valid line of Python has a specific meaning, and if you type it wrong, if you speak Python incorrectly, it will complain, all right? Okay, whereas for Scratch, it was like, if you can build it, it will run, okay? Python, that's not true anymore, okay? So I think that's where I want to start us, and let's just do super simple stuff in this thing called the REPL, because it's going to read, evaluate, and then print, and just keep doing it. So what the REPL shows us are these 3 lines, and that is one line of Python that we can write, and then we hit enter, and it will run. So I can hit enter right now having typed nothing, and nothing happens. Oh, that's technically a program, right? Well, let's do other things. We can say, all right, 42, hit enter. Ooh, okay, so 42 was the program, it ran, and 42 is the answer. So you see how it's going to do it? Your code, you press enter, and then the result of running that code is displayed below that line. Okay, and then it's in a loop. It's coming back. It just read, it evaluated, it printed out the answer. Now it's going to loop back to wait to read again. Okay, so here it is waiting for you to say something new. 43. Hit enter. All right, so you can do simple stuff with the REPL, like math. So I can say, I don't know, 42 times 42. That star means multiplication. And it'll tell you back the answer. All right, so maybe we should save some of this information. Dun dun dun. Star for multiplication. Slash for division. Percent sign for remainder. Things like that. And then plus and minus are normal. Let's see, what else? There's 2 stars for to the power of. So for example, 2 to the power of 3, that's 8. Hit enter and I'll do it for you. And you can do arbitrarily complex things here, of course. Be like, I don't know, 2 cubed times 42 divided by 7.5 plus 3.14. And it will just go off and be like, yeah, I know what to do. It'll follow the order of operations, of course. So the exponents first, then left to right, the multiplication, then the division. I guess it's all going to work in order this time, but you get what I mean. So you can do math, which is nice because you can just pop open Python and suddenly you don't have to break out your calculator. Be like, hey Google, what is 2 plus 2? It will do it much quicker than having to send something through the internet. Okay, so those are very simple things. You can do a lot of math. That's totally fine. But what happens if I want to do something more complex? What happens if I want to do more than just numbers? Okay, so you can type in a number and get back a number. We have discovered that. What other things are there? So there's a concept of types. Actually, I think I just want a new slide for this. So in Scratch, we did not have this. Okay, this is a new kind of thing. So types are the kind of data that you have at your disposal. So the type is the kind. Those are synonyms. This is hard to define. I don't know. Think of a type as a cloud, in which you can only put certain kinds of things. There is, for example, an integer cloud, where you can put whole numbers. And I'll call that int for reasons. So here's the int cloud. And I can put 3, 4, negative 42, etc. whole numbers. Int. Lowercase. It's important for it to be lowercase. Whole numbers. If I want numbers with decimal places, I can use the float type. Okay, so that will hold my 3.14 or my, I don't know, 7 times 10 to the 400, things like that. Things with decimal places. Oops. Okay. Oops. Again, lowercase, because that's what Python uses. So technically, any int can be made a float quite easily. You just add some point zeros at the end. Okay, what about other things than numbers? Well, how about text? Text can go between double quotes or single quotes. Python doesn't really care. I think it actually prefers single quotes. Okay, this is called str for string. And you can put hello, hi, things like that. Str, it stands for string. And you can think of it as like a string of characters, for example. It's just a bunch of things in a row, like maybe on a friendship bracelet. Some beads with letters on them, perhaps. It holds, so a str, or a string, holds a bunch of characters. So, that means there's a difference between 42, the string, in either single quotes or double quotes, and then 42, the number. You see the difference? Boop and boop. Okay? Now, let me show you some fun string things. Plus and times work for strings. What do you think that they would do for strings? For characters? What does hello plus hello even mean? Well, let me show you. Oh, sorry, gotta use a string. Take your bets. Oh, that's kind of logical. It gives back a new string that is those two together. Okay, I can build things up like that. I like that, I like that. 42 times 7. What do you think that means? Well, actually, you can probably guess pretty easily based on what plus does, because multiplication is just a lot of pluses, right? Aha! That is very, very different than 42 times 7, the numbers, okay? So just notice that. This is a string times a number, and a number times a number. Completely different things. Stir times stir times int. It's completely different from int times int. Okay? So if you get nothing else out of this slide, it's the types matter now. They tell you what kind of data you can have. Okay? And so with that, let's get into printing. Input and variables. So this is the REPL. It will just do one line at a time, but programs consist of multiple lines. We eventually want to get out of this REPL, and I think now is the time. Okay, so you can go to File, New File, and now we're outside of the REPL. Now we just have blank lines, okay? And this is a Python program. Python programs consist of a bunch of lines of Python statements. We say that each line is a statement, okay? That's just fancy terms. And, well, they execute one after another, just like Scratch. Okay, so I'm going to save my program. It's completely blank right now, but I'm going to save it. Save. And I will save it, I don't know, in my documents folder for now. And the type of file is .py for Python. Okay? I don't know where to put that, but it's always program.py. This is the Python file extension for a Python program. Okay? It signifies that this is a Python program. Technically not required, but it's very commonplace. All right, so I'm going to call this, I don't know, Hello World. How about like that? Because we're learning a new language, we should always write Hello World. So I'm going to save it. And now I've saved my blank file. I can go to run module. You go to run and then run module, or type F5, and it will run the entire program. Okay? Click it, and it brings it, and it runs it inside this REPL here. Okay? And so it, of course, has no output, but this is the result of running that one file. Okay? It's empty right now. Dun dun dun. All right, all right. Are you ready? Are you ready for Hello World? Because we have to have our Python program announce that it is sentient. So let's make a Python program that prints Hello World to the screen. And so, whereas in Scratch we had we had say, now we have print. Okay, and so that's why I keep saying print all the time in Scratch. So we can say not Hello World. Eventually we need to give it this string, but watch what happens. Nothing. This is not the REPL anymore. This is a Python program. And so just typing something does not actually print anything. The REPL printed the answer for us because that was what it did. It read, evaluated, and then always remembered to print. In Python, we don't always, every time we write a line, want it to print something. So we have to tell it to print using the print function, we call it, okay? So this is my one line now. It's print, an open parenthesis, the string that I want printed, and then a closing parenthesis. And if I go and I run this, ooh, we have our program. That's pretty. Okay. So, I think, let's talk about print. Or maybe we should just talk about functions in general. So, this is just interesting terminology. You'll hear this again and again. But here is what's known as a function call. Print is what's called a function. And we gave it something to print. We gave it a string to print. Okay? So print is the name of the function. And what we gave it to print goes between parentheses. Okay? And this is called an argument. Of the print function. And so this is one line of code, and once it runs, it will print what you told it to print, the string, to the screen, okay? And so print is like some code that somebody wrote for you. It's like the block, it's like the say block. And by running in this way, it will do what you asked it to do. Okay, so that is a function call. Optionally, functions might give back answers, okay? And we'll talk about that on the math library bit. So there's more to this. There's a possible result. So in general, let's say, maybe just on a blank slide. No, thank you. In general, here's what functions look like. You say func, name, you give it a parenthesis to start the function, and be like, all right, here's my first argument, here's my second argument, on and on and on till the end. Maybe there's n arguments. And then possibly it might give back an answer. And you can save that using this equals assignment statement. And don't worry if this is all overwhelming right now. I'm going to walk you through each of these. So, multiple arguments. Go between parentheses. And functions, potentially, this whole thing gives back an answer. Some functions may give back an answer. Others don't, like print doesn't. It makes no sense to say, ah yes, I printed. My result is fill in the blank. There is no result. But once we talk about like the math library, then things are more interesting. Okay, so we made our first program already. Here's hello world. And you know how in Scratch you could say to the programmer, be like, add a comment, be like, this is not actual code that runs, it's just something that's helpful. You can say, like, this says hello. And this doesn't affect the program. You can have comments in Python as well. Dun dun dun. Where do I want to put this? Oh no. Comments. Or maybe it's probably easier to type. So single line comments. Begin with a number sign. Multi-line comments begin and end with 3 quotes and oh no, those kind. I don't want spaces in between. Alright, so multi-line comments begin and end with these 3 quote things. Alright, so I don't know, this is all that's on the slide. Maybe we can make this large. But here's how we write a comment. This is not going to get run. So I can make a single line comment with just a number sign. And you see it's a different color now. This is a comment. It is not actual code. So it doesn't get run or anything like that. And you can put them on any line. You can put them after your normal code. Even. Isn't that cool? You can comment up your entire program as much as you want, and here's a multi-line comment, also won't get run. Oops. And technically you can use single quotes as well. And I think it's just muscle memory for me to use double quotes because I'm teaching CSCI 40 and 41 at the same time. But if you want to be a real Python programmer, a Pythonista they say, you'll use single quotes for your strings, even your long multi-line comment strings. Okay, that is printing. Let's talk about variables for a second. And just to prove to you that this runs and does exactly what it says, there it goes. All right, so now let's talk about variables and assignment, because this is going to get interesting. And just like in Scratch, you can make things to hold other things. So you can name variables in Python to hold values. And you have to, your variable names cannot hold spaces or special characters. There is a little rule, and you might want to look it up, but I think I'll just gloss over it probably. Or special characters. No, let's just say the rule. So variable names have to start with an underscore or an alphabetic character, A through Z, comma A through Z. So these are your options. Capital or lowercase or underscore, your variable names have to start with that, and then after the first letter. They can be followed by more underscores, more lowercase letters, more capital letters, and also you can have digits. So for example, in Python you can have variable names, x of course, you can have underscore underscore x underscore 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 blah 42, but you cannot have 42 blah. Cannot start with a number. Okay? That is not allowed. So let's make some variables to hold things. We can make them hold values using what's known as an assignment statement. Okay? And all that means is you have variable name, an equal sign, and then possibly a complicated expression that becomes a value. Da, da, da. Okay, so for example, let me make a new file. Ooh, it's just gonna give me a bunch. That's fine. I can say x equals 42. Okay, and this line, after it's run, it will make a box in memory called x, and it will put 42 inside. Okay, so after that line gets run, remember that they get run in order. So now, after this line has been completed, just the program goes down to the next line. So now after this line is finished running, x is a variable that holds 42. Okay, so we can say print x, and it will print out the answer, x. But it will figure out that x is 42, of course. So let me save this. And let's see. I'll just call this vars, and it'll be vars.py, I guess. See how this one was named helloworld.py? So I'll say print x and go and run it. And it prints 42 because x is 42. And I can inspect the program and be like, oh, okay, what was x? It was 42. Aha. So the REPL is super nice. After you run your program, you still have access to the variables inside the REPL. So yeah, we made this box called x. It held 42. We printed out x, which was really 42. Okay? And we can do complicated things, of course. We'll be like x equals 41 plus 1. And this is no longer just a simple expression. It has work that needs to be done before it gets put into x. So Python has to do some work before it puts anything in x now. It has to execute, it's a program, make a value out of the right-hand side of the equality. That assignment statement. Okay, so whatever's over here, it needs to bring it down to a value in one of the nice clouds, and we know what things each of those clouds holds as simple values: whole numbers, numbers with decimal places, strings, a bunch of characters. So right now, we're not yet at a simple value. We have an expression that needs to be converted to a value. So eventually this will become an int, but right now it's not. Okay? And if you ever wonder what the type of a variable is, or anything, you can say type x, and we can print that out. And I can type F5 to run the program. And it's like, it is an int. You can also say, what is the type of 42? It's an int. What is the type of 3.14? It's a float. The type of ASDF. It is a stir for string. Okay? And of course there are many more, but this is just an introductory lecture, of course. So, alright, this is nice. These are variables. We're using them. We can make more. We'll be like, alright, y equals 37. Let's see, print y times x. Why not? So that's a thing. We can use variables to do other things, and apparently this is 1554 when we go and run it. I'll make this smaller so we can see the program and the code at the same time. There you go. What do you think happens if I do this? Y equals y plus 1. So right here, before that line, right here, y holds 37. Okay, so y is sitting in memory. It holds 37. That's a bad 3 and a bad 7 and a bad y, I'm sorry. Holding 37, minding its business, and then, bam, we do this. What in the world does this mean? And the way that I want you to understand this assignment statement is it always worries about the right-hand side first. Right-hand side gets executed first. So now we know the order. This is easy. Well, what's y plus 1? It's 38. So this all becomes 38, okay? And then it puts it into y. This is the second thing that happens. After this becomes a value, then we put it into y. So now y holds 1 more than what it used to be. And that's interesting. You can update a variable like that using assignment, using itself. What? But of course, if I go to run, no, I'm going to have to print it out, of course. We'll see that y becomes 38. Okay, there it is. That's interesting, isn't it? So, before we move on, I want to talk one more thing about input. I guess the order is supposed to be printing variables and input. So, how do we get something from the user? In Scratch, we had the ask block. Like, hey, what's your name, dude? And then it'll store the answer right here. Well, in Python, it's quite similar. There's a concept of an ask block, and then there's a concept of the result, but they're a bit different because it's in code now. It's in straight lines of code. So, getting input. So in Python, there's an input function. And I'll write a function with these two little parentheses just to highlight the fact that it is a function. It takes stuff that you put inside of the parentheses, though, of course. So as arguments, it takes an argument that is the prompt to ask the user, and it actually gives back a result. That is the user's response. Okay? So this is all weird, but this is what it looks like. You can say input your name, question mark, space, and then store the user's response into a variable, maybe called resp, for example. So what'll happen is this will print out to the screen, hey, your name? Like this is your computer screen. Prints out your name and then a space, and then it's waiting for you to type right here. And so you can say Lawton and press enter. Boop, boop. And once you press enter, it then gets your name from the input and puts it in a variable called resp. And suddenly, resp holds that string that you typed in. Alright? So it gives back a result. That is the user's response. Isn't that cool? So let's do that. And we might not have enough time for the math library today. We might have to hold on to that for next time. But we're doing well, I think. We'll call this one, perhaps, input.py. So we'll say resp equals, and I have more room to type here, so I can say, what's your name? And even the Python, this idle thing, this program is telling me helpful things, like what kinds of things that input needs. So you can give it just one thing, and that is the prompt. So, what is your name? Question mark. And there's a reason why I put a space here, and I'll show you what it means when I don't have one. So I can save and run this. And right here, it's like, what's your name? And then it waits. It waits for you. And then you can type your name and hit enter. And the reason you want to put a space here is because this just looks ugly. Type in Lawton next to a question mark. Okay? So we put a space here to separate. And sometimes like people put colons in spaces. You can get as fancy as you want, but I'll put a space. And then you can respond with print hello, comma, space. And we know what plus means. Resp. What do you think this does? So this will get my name, put in the resp variable, and then it'll print out hello plus resp. What? Run this with F5. What's your name? It's Lawton. Hello, Lawton. Oh, how cool is that? And of course, we can add more things at the end of that. Put an exclamation point if we wanted to. Isn't that cool? So resp gets input. And resp's inputs are always strs. So type resp. It's always going to be a str, even if you type in a number. Okay, so print type resp. So you see how this is a function call within a function call? That's not a problem. So print whatever the type of resp is. Even if I type, hey, my name's 42, it's still a str, okay? Everything input gets is a string. Or it gives back. Excuse me. So I think that is what I want to show you here. Let me just tease you a little bit with the math library, because this is important. So let's go back to Google and be like, Python math. Hit enter. And this will give us the Python documentation. Usually the first hit's the right one. Python 3.8.5, yeah. Math, beautiful. So this is where you will live a lot from now on. This is the documentation for Python. And Python is super nice, and one of the main reasons, is that it has a lot of library support. So a library is just a bunch of code that's been written for you. It's like a bunch of books, like that you go to your local library and can check out. Like, you don't own them, but somebody else made them for you, and you have the ability to use them. So a library is just a bunch of code you can use inside of your own programs, pre-written. You can use inside your own programs. So that's that. And let me show you some of these math functions that exist. Math.ceil, math.comb. What are some ones that we know? Let's see here. Ooh, exp, you might know that one. It takes e to a certain power. The logarithm, math.log. Square root, we definitely know that one. And maybe we can do some trigonometric functions as well. Yeah, math.pi. So let's see a few things here. So when we want to use the math library, we have to import it. Dun dun dun. To use the math library, and it's lowercase, you have to import it. Okay? And that's the technical term, import. And we say import math. To do it, lowercase. That's all we need. And then suddenly we have access to things like math.pi. And it's always the name of the library, dot the stuff inside. Libname dot thing we want. Thing inside of the lib. Lib for library. Math.pi, that's not a function, it's just a number. It's just a variable that got defined for us. Say math.square root. Math.sign, etc. And these two are functions. This one's just a variable that's predefined. All right, so let's use the math library a little bit, and then we'll be out of here. And these documentation pages are super helpful in that they tell you exactly how you can use all these things. And return is just a fancy word for giving back an answer. All right, so math.sign of 42 returns or gives back the sign of 42 radians. All right, so let's do this. One new file, one more. We'll say math. We'll call this math.py. And we'll say import math. Ooh, this might be a problem. We'll see if it's a problem in a second. And I might have to rename this. Import math. Let me print math.py. Let's see if it'll allow this. Okay, it's gonna work. Cool. There is a problem with using a library the same name as the program that you're writing, but I think it's not an issue right now. So it prints out math.pi. Hey, that's super nice. We can say math.square root something. 42. And then it'll print that if we run it. It's apparently that. This value down here. I'm going to say math.sine of pi. How about that? And this is supposed to be 0, but it's not, and we might have to save that for a future lecture. But perhaps cosine of 0 at least will give us a nice even value. There we go. We get a 1.0 out of that. So I think that's where I want to leave us. We'll have to talk about number conversion next time, but this is a great place to stop. So we have just talked a bit about Python. Hopefully you can get that installed. Please come to office hours, yell at me, I'll help you. I'll give you all these files that you can run in your own version of idle. And yeah, just play around. That's how you learn. These documentation pages are a lifesaver. And you can take a look at all the different libraries that Python has. There's more than just math. You can go to the table of contents, play around. But yeah, that is our introduction to Python. I'll see you next time.